This is part 2 of lecture 1.1 of Math 108, Introduction to Logic and Negation, Conjunction, and Disjunction. In this video, we will give more examples of propositional forms involving the negation, conjunction, and disjunction operators. Recall that a propositional form does not have a truth value, but instead it has a truth table. The truth table of a propositional form is simply a table showing all possible combinations of truth values of the variables together with the resulting truth value of the propositional form. To illustrate, let us show the truth tables of the propositional forms not P, P and Q, and P or Q. For brevity, we use the symbol T for true and F for false. A proposition P has only two possible truth values, so the truth table for not P has only two rows. By its definition, the statement not P is true exactly when P is false and is false exactly when P is true. This is the truth table of the statement not P. Each proposition P and Q has two possible truth values. So there are four possible combinations of truth values of P and of Q. Thus, the truth table of P and Q has four rows. By its definition, the statement P and Q is true exactly when both P and Q are true. Hence, it is false whenever P is false and Q is true, P is true and Q is false, or both P and Q are false. This is the truth table of the statement P and Q. The truth table of P or Q also has four rows. By its definition, the statement P or Q is true exactly when at least one of P and Q is true. Hence, it is true whenever both P and Q are true, P is false and Q is true, or P is true and Q is false. It is false exactly when both P and Q are false. This is the truth table of the statement P or Q. Let us apply these to find the truth values of the statements in our previous example. Our two propositions are the statement P, the number 29 is prime, and the statement Q, the principal square root of 16 is equal to -4. The proposition P is true, while the proposition Q is false. Thus, for item 1, the statement the number 29 is not prime, which has the propositional form not P, is false. For item 2, the statement the principal square root of 16 is not equal to -4, which has the propositional form not Q, is true. For item 3, the statement the number 29 is prime and the principal square root of 16 is equal to -4, which is the conjunction P and Q, is false, since Q is false. For item 4, the statement either 29 is prime or the principal square root of 16 is -4, which is the disjunction P or Q, is true, since P is true. For item 5, the statement either 29 is not prime or 29 is prime and the principal square root of 16 is not equal to -4 is slightly more complicated and requires a more detailed analysis. The corresponding propositional form to this statement is not P, or open parenthesis, P and not Q, close parenthesis. Since P is true, not P is false. And since Q is false, not Q is true. Thus, the conjunction P and not Q is true since both P and not Q are true. The disjunction of the statements not P and P and not Q is true, since the statement P and not Q is true. Therefore, the sentence either 29 is not prime or 29 is prime and the principal square root of 16 is not equal to -4 is true. For the next set of examples, we are to identify the underlying propositional form of the given proposition and use this to determine the truth value of the proposition. First, let us consider the statement, the square root of 2 is rational and either the square root of 2 is greater than 1 or the square root of 2 is less than 2. The simple propositions that make up this sentence are as follows. The square root of 2 is rational, as well as the mathematical statements, the square root of 2 is greater than 1 and the square root of 2 is less than 2. Let us denote these by P, Q, and R, respectively. We now describe the abstract logical structure of our sentence using the symbols P, Q, and R, together with the negation, disjunction, and conjunction operators and the appropriate grouping symbols. The first part of the sentence is the statement P, followed by the word and, which signifies a conjunction. The second statement in the conjunction is Q or R. We know that this is treated as a single statement and hence is enclosed in parentheses because the word either appears before statement Q, which signifies that Q is the first statement in the disjunction. The truth value of the whole sentence depends on the truth values of P, Q, and R. We know that statement P is false, statement Q is true, and statement R is also true. Thus, the disjunction Q or R is true. However, since P is false, the statement P and the disjunction Q or R is false. Therefore, the given statement is false. Next, we have the sentence, either the square root of 2 is rational and the square root of 2 is greater than 1, or the square root of 2 is less than 2. We have the same propositions P, Q, and R as in the previous example. The first part of the sentence is the conjunction P and Q. We treat P and Q as a single statement and enclose it in parentheses, because it is preceded by the word either and followed by the word or, which signifies that it is the first statement in a disjunction. The second statement in the disjunction is the proposition R. As in the previous example, P is false, Q is true, and R is true. So the statement P and Q is false since P is false, and the statement either the conjunction P and Q or R is true since R is true. Therefore, the given sentence is true. Observe how this example and the previous one involve the same propositions P, Q, and R, and the same operators and or arranged in the same sequence, but with different positions for the grouping symbols. The sentence in example 1 is false, whereas the sentence in example 2 is true. Thus, these two sentences have different meanings. This illustrates the importance of using grouping symbols correctly. Changing their position could completely change the meaning of a statement. For the third example, consider the sentence, it is not the case that both 2 and the square root of 2 are rational. The proposition both 2 and the square root of 2 are rational can be written as 2 is rational and the square root of 2 is rational. Thus, The two simple propositions that make up the sentence are 2 is rational and the square root of 2 is rational. The phrase, "it is not the case that," indicates a negation. Since it precedes the word both, this means that we take the negation of the entire conjunction 2 is rational and the square root of 2 is rational, which we treat as a single statement. Since P is true and Q is false, the conjunction P and Q is false. Hence, the negation of P and Q is true. Therefore, the given sentence is true. Next, let us consider the sentence, "Neither 2 nor the square root of 2 is rational." This can be written as the statement, 2 is not rational and the square root of 2 is not rational. Let us take P and Q to be the same propositions as in example 3. Then, with this choice of P and of Q, the first part of the sentence is not P, followed by the word "and," signifying a conjunction, and the statement not Q. Since P is true and Q is false, not P is false and not Q is true. Thus, the conjunction of not P and not Q is false. Therefore, the given sentence is false. For our last example in this set, consider the sentence, "Either both 2 and the square root of 2 are rational, or neither of them is." As in the previous examples, we can write the statement, "Both 2 and the square root of 2 are rational," as 2 is rational and the square root of 2 is rational. The statement, "neither of them is," means neither of them is rational, which can be written as 2 is not rational and the square root of 2 is not rational. Take P and Q to be the same as in examples 3 and 4. The proposition, "both 2 and the square root of 2 are rational," is the conjunction P and Q. It is preceded by the word "either" and followed by the word "or," which signifies that it is the first statement in a disjunction. Hence, we treat it as one statement and enclose it in parentheses. The proposition, "neither of them is rational," is the conjunction not P and not Q. Since it follows the word "or," it is the second statement in the disjunction and thus must be enclosed in parentheses. Since P is true and Q is false, not P is false and not Q is true. So the conjunction P and Q is false, and the conjunction not P and not Q is also false. Therefore, the disjunction "either both P and Q" or "both not P and not Q" is false. Thus, the given statement is false. For the last set of examples, we are to construct truth tables for the given propositional form. Assume that all letters represent unknown propositions. First, we have the conjunction not P and not Q. Since there are two variables in this propositional form, the truth table has 4 rows, corresponding to the 4 possible combinations of truth values of P and Q. For clarity, we include 2 columns for the truth values of not P and not Q. The truth values of not P and of not Q are the opposite of the corresponding truth values of P and of Q, respectively. The conjunction not P and not Q is true exactly when both not P and not Q are true, and is false for all other cases. Thus, not P and not Q is true exactly when P is false and Q is false, and is false for all other cases. Next, we have the conjunction of P and of the disjunction Q or R. Since there are 3 variables in the propositional form, there are 8 possible combinations of truth values of P, Q, and R. To help with our computations, we also include the column for the truth values of the disjunction Q or R. The statement Q or R is false exactly when Q is false and R is false. The statement Q or R is true for all other cases. To obtain the truth value in the final column, we only need to look at the truth value of P in the first column and the truth value of the statement Q or R in the fourth column. The conjunction of P and of the statement Q or R is true exactly when P is true and the statement Q or R is true. Thus, we get the resulting truth value as true, false, true, false, and so on. The rest of the table is left as an exercise. You have come to the end of part 2 of lecture 1.1. Before you proceed to lecture 1.2, be sure to answer the exercises included at the end of these slides. Thank you for your attention.